In this question, we have been given acceleration versus time graph. Acceleration is in feet per second square, time is in seconds. We have to find out the distance covered by the object in these 30 seconds, and we also have to find out the position time graph. Okay. Now you can see here the acceleration is plus 5 for first 10 seconds, then 10 to 20 seconds it is 0, and for 20 to 30 seconds it is minus 5. It is decelerating. Okay, now what we are going to do is to find out the distance. We are going to construct a velocity time graph. Okay, let's do that. Now in this question it will be assumed that the initial velocity is 0 because it is not given, and without that you cannot do this question. So let's assume u is equal to 0. Your u is equal to 0 meter per second. Now we want to write velocity as a function of time, right? To draw the velocity time graph. See, they can also ask velocity time graph. In this case, they have asked position time graph. They can ask velocity time graph as well. So it is better to do it velocity time graph and then find out the distance. Without that also you can find out the distance, but it is better to go this way as of now. Let's see, u is 0 meter per second. Our time is 10 seconds. So after 10 seconds, what is going to be the velocity? That will be v is equal to u plus at. So u is 0, so v is equal to at, right? So this is the formula, and a is equal to plus 5 for 0 to 10 seconds. So this is 5 times t. Okay, at t equal to 10 seconds, the velocity is equal to 50 meter per second. So at t equal to 10 seconds, velocity is 50 meter per second. This is going to be the velocity. Okay. Now, till 0 to 10 seconds, we will follow this rule. Okay. Now, let me plot it. Let me plot this. This is y-axis, this is x-axis, this is time, this is velocity. Oh, this is feet, right? So, let me write it as feet. This is feet per second, and this is second. Okay, phi t means for 0 it is 0, t equal to 0, v is 0, and it is a straight line with a slope of phi, and at this point, that is the 10 seconds, the value of this velocity will become 50 feet per second. Okay, this is 10 seconds, right? Now in 10 to 20 seconds, it is having a zero acceleration. That means it will continue moving with the same velocity for another 10 seconds. Let's draw it like this. So that is 20. I think this and this are not equal, but it's okay. We have little space only. Now, from this velocity, it will decrease because of the negative acceleration, minus 5. So that means you have v is equal to, I will write it as, okay, I will write it as v only. Okay, but now the initial velocity will be different, which will be 50. So let me call it as u dash plus acceleration is different times t. Now acceleration is negative, so v is equal to u dash, that is 50 minus phi t, right? Now when t is equal to 0, v is 50, and now if t is equal to okay, so let me draw it here. For t is equal to 0, it is 50. So let me take this as 20 to 30. Okay. Now, considering this as my 0 time in this case, right? I am taking this as my origin of time for this case. So if t is equal to 0, v is 50. That is the correct one. And in 10 seconds, what will happen in next 10 seconds? It is going to be 50 minus phi into 10, that is again 0 meter per second. So the velocity becomes 0 in yet 10 more seconds. So here it will go down like this. The slope of these and these are equal in magnitude. Okay, the signs are opposite. Now you can find out the distance covered in 0 to 30 seconds. Now this, see, this is a displacement velocity time graph. area under curve is a displacement, but in this case we will say it is a distance as well, because no part of graph is below the time axis, right? So everything is positive, so distance and displacement will be same. So this is a trapezium, so the distance basically will be half into sum of parallel sides, that is 30 plus this 10, 30 plus 10 into height is this 50, so this will be 40 by 2 into 50, so that will be 1000, right? 1000 feet. So this will be the distance covered, 1000 feet. This is one part of the question. We will look at the next part now. Now I have drawn this velocity time graph here in a smaller format. Now I want to find out the position versus time graph. How will I do that? Let's look at this. So now from here 0 to 10 seconds, the velocity is increasing at a constant rate, right? What was the equation? Let's say, I think, is it visible? Yeah, it's visible. So initial velocity u is 0. So let me draw this. This is our origin, okay? And this is our right direction, which is positive, and left direction, which is negative. All the acceleration towards right will be positive, all the acceleration to the left is negative, and all the displacement velocities towards right will be positive, and all the vector quantities towards left will be negative. Now initially it started from this point, let's say origin, and till 10 seconds it has covered some distance, I don't know. So what I am going to do is, let's say x is equal to ut plus half at square, right? So u is 0, so I can write this as half into phi into t square. So this is going to be phi by 2 into t square. This is your x. Now x versus t graph, if I see for 0 to 10 second, it is a parabola, right? It is a parabola. So now I am going to draw it over here, okay? Let's say this is t, this is x. Now here this is origin, at t equal to 0, x is 0, right? And this is 2.5 times t square. So it is a parabolic curve till 10 seconds. So this is 10, and this position will be how much? If you put 10 over there, it will be 100 by 2, which is 50, that is 250 feet. So this is 250 feet. I am writing feet over here and seconds over here. Okay, so till now it is parabola. After that, velocity became constant. Now velocity became constant, and what was that velocity? 50. So here the equation will be for, this equation is for 0 to 10 seconds. This equation is for 0 to 10 seconds. Now for the second case, what happens? The velocity is constant, 50, and this is for 10 seconds. So now your position after this 250 feet, after 250 feet, my position x will be given as simply velocity into time t. So velocity is 50 into t. So it will increase with a rate of 50. Now I will take this as origin, my initial point, and it will be with a straight line, right? So it will go up with a straight line for another 10 seconds. Let's say this is 20. So this is 250, right? So in another 10 seconds, it will go 500. So this is more 500. So from the origin, it is 750. From the origin, it is 750. More 500, right? So it has gone 750. So this is for time t 10 to 20 seconds. This is for 10 to 20 seconds. Now, for 20 to 30 seconds, how we will plot the graph? So for 20 to 30 seconds, let's say this is the third case, right? T is equal to 20 seconds to t equal to 30 seconds. Can you see that at this point the velocity is still 50 feet per second? So I know if I draw x, if I write x, after this point, after this time, after 20 seconds time, I am taking x is equal to, initial velocity is already plus 50 into t plus half into the acceleration. What is acceleration in 20 to 30 seconds? It is -5. So I am going to write, this is plus, okay? This is -5 into t square. Now x is equal to 50t minus 5 by 2 into t square. So this is 50t minus 2.5 t square. This is what you will get. Okay, now how will I plot this? Okay, it doesn't look like a simple parabolic. It is a parabola. It is a parabola, but it doesn't look like a simple parabola like x square or even x minus 2 whole square like that. It is something x square minus some constant times x. I don't know how to plot this. So how will I do this, right? Okay, so to do this, what I am going to do is I am going to use a method called completing square method. So before I plot this, I will just give you a recap of how to plot the functions. So y is equal to x square. You plot it like this. Okay, this is a parabola. Y equal to x square, you plot like this. Simple. Now y equal to minus x square, how will you plot? Just simply you just flip this like this. So this okay, don't see the slope. It should be exactly the mirror image, right? So this is y equal to minus x square. Why? Because every value will become negative by multiplying it by -1. So here all the values become negative and it will be like this. Okay, if I want to find out y equal to x square plus 4, then this whole graph will shift upwards by 4, because all the values, right, if I put x equal to 0, it is no longer 0 now, it is 4. So all the values will shift up by 4. Same goes with x square minus 4, it will shift down by 4. Okay, now in such a case it is difficult. So I will tell you one trick to plot this equation. So what I am going to do here is, just watch. I am going to use a completing square method. Completing square method. See how to do this. You have your x is equal to 50 into t minus 2.5 into t square, right? So I am again rewriting this as minus 2.5 t square plus 50 times t. Now I am going to take out 2.5. Let's take out minus 2.5. So it will be t square minus. Now this will be 20, right? 2.5 into 2 is 5, into 10 is 10. So 20 into t. Okay, right. Now look at this. This is not a completed square, right? So I am going to do, what I am going to do is I am going to add and subtract one number. So the coefficient of t square is a, just like your quadratic equation, right? Ax square plus bx plus c. So here a is 1. Here I am assuming I am taking 2ab value as 20. Now from here, if I put a as 1, b is going to be 10. Now I want to add b square and subtract b square in this equation. So if I do that, I will get x is equal to minus 2.5 into t square minus 20t plus 100 minus 100. This is what I get. Okay, so this x becomes minus 2.5, and this you can see as t minus 10 whole square, right? This t minus 10 whole square minus 100 minus 100. So if I multiply this again, minus 2.5 into t minus 10 whole square plus 2.5 into 100, which is 250. This is your x as a function of time. Now this is pretty much easier to plot compared to directly seeing this. I will tell you how to plot this. Okay, let me see if it is visible. Yes, barely just visible. Okay, just visible. Okay, now let's plot this equation. So I am going to forget everything because that is not relevant now. What is relevant is this equation. Let me rewrite the equation over here. it is minus 2.5 into 10 t minus 10 whole square plus 250. Okay, so right, so we will take this as our origin. So here if you take t as 0, if you take t as 0, it will be 0 minus 10 whole square, this is 100, 100 into 2.5 is 250, so this minus 250 plus 250, that means x is 0. Now you will say, oh, for t equal to 0, that means t equal to 20 seconds here. I am taking this as my origin point over here. That's why it is appearing like that. Okay, so that is 0. Now, after 10 more seconds, what is going to happen? At t equal to 10, your x is going to be 10 minus 10 is 0, so this is going to be 250. So you are going 250 more than 750. So that is going to be 1000, right? So that is going to be 1000, and let's say this is 30. Let's say that point is somewhere here. Okay. So t equal to 10 more seconds after this point, it has gone 250 feet more. So that 250, if you add to 750, it is going to be 1000. Right. Now the problem here is that I don't know, I know this and this will be connected, but I don't know how they are connected. Is it a straight line? Of course it is not a straight line. If it is a parabola, then is it like this parabola, I don't know anything. So what I am going to see is going to see the shape of this parabola. Okay. Now how will I plot this parabola? That is the question. Now look here, I know y is equal to x square graph is something. Then what will be the graph of x minus 2 whole square? See, it is 3 minus 10 whole square, right? So what is y equal to x minus 2 square? So you know y versus x graph of y equal to x square is simply like this, right? It is known to you. But what is x minus 2 whole square? See, if I put x equal to 0 in this equation, I am going to get 0. Y is equal to 0. So x 0, for x 0, I am going to get y is 0. Very good. For x equal to 1, I am going to get y is equal to 1. For x minus 1 also, I am going to get 1. Same thing. It is a symmetric about y axis. Now, for x equal to 2, it is going to be 4. But here, if you see, for x equal to 0, I am not getting y as 0, but rather y is equal to 4. Right? Y is equal to 4. Now, if I want to get y equal to 0, I have to add plus 2. I have to add 2 in this input so that I will get y equal to 0 for this equation. Now, if I want to get y equal to 4 in this equation, I have to put x equal to 2. But in this equation, to get the same value, that is 4, I am going to put 2 plus 2, that is 4. So that is 4 minus 2 whole square is equal to 4 again. So all the values, okay, of this will be matched to this only if I increase my input by 2, right? So you can see that this graph has gone like this, okay? Mind you the slope. So here the x is equal to 2. You can see for x minus 2, all whole graph shifts by 2 amount in the right direction. If you don't get it, just I am again explaining, for x equal to 0, you are getting y equal to 0, for y equal to x square. And for y equal to x minus 2 whole square, is it visible? Yeah. For x minus 2 whole square, to get the same value, my input should be 2. Then only I will get y equal to 0. If my x is equal to 2, then y is equal to 4. To get the same value of 4, I have to input 4 to get y is equal to 4. So all the input values are increased by 2, right? So that means the same values of y will only occur when I shift this by 2, right? So this 1 and 1 will be, for y is equal to 1, it is 1, yeah. So this 1 and 1 will be intersection of these two. Okay, so this is shifted. So here also this graph will be shifted by 10 in the positive direction. If it was plus, then we have a shift towards left. You can see that. Okay, so now this graph is t minus 10 square. It will look something like this. As here the x y equal to x square has gone by 2 in the right direction. Similarly, this has gone in the right direction by 10. So it will be somewhat like this. Okay, this is t equal to 10 and this is y and this is t, right? This is gone in 10. And now you multiply it with a minus, so it is going to flip downwards like this, right? It is going to flip downwards because of this minus, and it will increase. This is a scaling operation, so it is not exact mirror image, but yeah, if you say this is 2.5 into t minus 10 whole square, then it will be exact mirror image. If it is not, if you just consider it as t minus 10 square, then this will be scaled accordingly. But it is mirror image. It will be going down like this. Okay. Okay. Now see this value. Okay. This value at t equal to 0 is minus 250 in this case. If you just remove this, if you put 0, it will be minus 250. So this intersection is minus 250. Now what is happening is I have to take this graph upwards by 250. So now I am going to push this graph upward by 250. So eventually the graph will look something like this, and it will stop here because I want till 10 seconds. So this is x. So x versus t graph is looking like this parabola. Okay, so here this is a parabola, but it is like this. Okay, now what is this point? See, what is this point? This point, if I take a differentiation over here, dx by dt, it will be minus 5 into t minus t. Velocity as 0. So velocity v is 0 at what point? At t equal to 10 seconds. Right? So at 10 seconds the velocity is 0, and you can see here clearly after 10 seconds from 20 seconds, that is at 30 seconds, here if you see the slope of this is 0, the slope of position versus time graph. That means the velocity is indeed 0 at t equal to 10 seconds. 10 seconds from 20 seconds, okay? That is the thing. So the overall graph will looks like this. This is a parabolic increase because of acceleration is positive. After that it is a constant rate of increase of position, and then it is going to stagnate at this point, the position. After that it will switch to this. This is a maxima, by the way. After that it will come down, okay, if the acceleration persists like that. Thank you.